Being recorded. Now, before get started, I want one thing from you guys. Can you write down in the chat? Either have you started with, have you ever tried the generics, or you know the basics, or are you kind of expert in generics? Can you write down in the message, one or two people, so that according to that I will maybe go more depth, start with basics. Okay, I know basics. I know intermediate. Okay, people know basics, intermediate. Still, there are things like in extension functions and multiple uh, parameters and constraint base. So we can maybe start from there. So from basics, but the generics, and then we can move to the multiple constraint and runtime of generics. Okay, cool. Let me share my screen then. Okay, entire screen. Okay, cool. So let's get started on this one. The genetics in Kotlin. It's this topic is kind of big. It's not easy to explain in a one tech talk because it might contain a lot of small things which will get left. So I divided into first part, and second part will be more in depth. So in first part, we'll from basics to mediocre level. Basically, we'll going forward from genetics to the runtime of it. How will it look in runtime? And maybe in the next part we will start more into more depth like covariance, introvariance, and all those kind of things. Okay, cool. Let me start with the first of all introducing myself. My name is Ankit Kumar, and I'm currently working in a Gojek as a software engineer on Android and Flutter both. um, and also I'm a part of Android educators as well. So yeah, that's all about me. Without further ado, we can jump into this. um, So, what is generics in Kotlin? Not only Kotlin, if you look at the any other language, the generics terms will be coming in. When you start learning a language. So it's very important in a language to use generics. It's basically give you so much power to make your code more flexible, make your code more reusable to the other developers. And the idea of generics is always that you build a code that will be suitable to different kind of data types, different type kind of types that you can use in that code base that you have created. For example, you create a function to calculate something, and you want that function to not only be there for integer type. You want them to be any kind of data type that user or other developers might use your function to work with. So if somebody wanted to calculate something with the data type of double, maybe data type of their own class, so all their different type of data type will be suitable with your function. So you if you wanted to build that kind of function or APIs, that's where the generics whole agenda or everything of generics comes into the picture. That it's give you a power to create a single function that will works on the different kind of data types. And although in going forward you can apply a lot of constraint on it, so you give the power to developers that you can use different type of data type, but it should be inside some constraint as well. So we will learn from them. So basic the idea of generics is to create a function or class which will work off different data types. So generics in terms in normal, like it's generalized things. Okay. This generics has a different thing in Kotlin as well. So you can provide by using generics, you can make your arguments as type argument. What the type argument is basically, you did not say that my class will only work on integer. You will say my class will work on type, which means it can work of any type of data type, uh, which is there in Kotlin. Okay, which is we call the type arguments, which you can see in a string here. This is the list of type. Now this type can be replaced with any data type, either a string, integer, your own built classes, objects, right? And it can be single or multiple type argument. You must have seen map, hash map, right, which contains two data type or two type argument, which is maybe k and v. You can name your type argument any variable like k and v, a and c, anything. So they have multiple type argument. So that's the example of multiple type argument. You can create multiple type argument. It's not restricted to two. As much as you want, you can create multiple more for your class and functions. Also, this is inferred by compiler. So what I mean by that is, when you call your function or your class by this, for example, we have the name which create a list of string. Normally we also have to provide what kind of data this name going to be stored. So if we go to the basics, we have to add colon and then we have to add list of type string, right? But Kotlin compilers is smart enough to understand what it is being assigning from the right side. So by looking at the list of, compiler understand, okay, names going to be a data type of list of a string. So this, by this understanding of compiler, you don't have to write list colon and list string here by yourself. It automatically understand by the compiler and it will not throw you any error. And again, there are some comparison between Java and Kotlin. Why I choose Java? Because most of the developers come from the Java to the Kotlin. So we will look when we go into the more slides, that what are there in Java and what are there in Kotlin. So far so good. Now moving forward, we will start with the generics functions. So functions, we all know that Kotlin is basically object-oriented programming language as well as the functional programming language as well, which means that you can use function as a variable. You can pass the functions around and you can pretty much create the function without a class. Okay, so creating generic functions are also like we have both. We will be understanding both generics in function, class and interface, all these three, but we'll start from the functions. So this is the example that how you are going to create a generics function. So this is the example of extension function. If you have seen that I use list dot slice, so that means I wanted to create a function on a list class, which is an extension function. And then these are, you are seeing this t, right, starting from fun, and this return type. So we call this as a type parameter declaration. So you can name your type parameter t, r, k, anything. And from this type parameter you also provide the same to the return type. If you wanted to say, okay, the function, the meaning of this function is, you have created extension function of type t and you also returning the same uh, list with the type t. Okay, so we call it type parameter declaration and this is the return type. And this is the on the extension function on which class you are also providing a parameter. So if there is a class which does not it's not a generic class, you don't have to provide t here. If it's a normal, you can have. You can also create a variable with t here, but currently we did not. It's just getting the int range value. You can also ask for the different type of data type in the argument as well. So all you have to do is just create a variable name indices and make a type as a t instead of this int range. So now instead of this permanent int range, it will be a dynamic data type which will be a t. So whenever function or whenever somebody call your function slice, they can provide different data type. They can either provide integer, int range, or maybe double or anything. But currently it is explicitly specified that we will be always asking for int range. Okay, this is how you are going to declare your um, a generic function. And this is also example on the extension function. Okay, so also in the normal way. So I will give you this is the example of why we need generics. So let's say you have a company and you just showing a integer, right? You are showing a, sorry, string. And when you're calling and you wanted to print out the company name, first you provided the tag talk, which is a string type. And when you wanted to print the rank as well, you have to provide the integer, the string. But if you provide the integer, the compiler will give you an error. So that you can't reuse your same class or same function. So by using generics, this is how you're going to create a generic class. The class name and your type parameter. Okay, and by applying comma, you can add more type as well. Currently we are using a single type parameter t. So by using t, now you can get the t in a constructor as well. So the text will be of type t, that means it can be a multiple types, either string, integer, and you will going to print this text as well. And the assigning of this x will also be t, which is text, right? So whatever variable or whatever data type we are sending from the constructor, it will be assigning in a x. So x is also kind of a type parameter in a runtime. Okay, so before inferred generics, you have to first of all create a variable with a company name with a string as a type parameter, and this is the assigning of it by creating an object, company and string and tech talk. Now, if we use the compile infer type, you don't have to add string here. It will get understand from the constructor parameter. So if you use your type parameter in a constructor, compiler will automatically understand if you pass the data type. So if you pass here a string, so compiler will understand your company will be of type string. Okay, and this will assign x as a string as well automatically. So this is the advantage of compile inferred in the Kotlin. So you don't have to write boilerplate code by yourself. So when you, even though you give the 12, compiler will understand, okay, this is going to be integer, that means company will be of type int, and the object will be created of rank as a company type integer. Okay, so this is how you will create the generics in class. Moving forward, uh, so also just generics function as well. I hope you guys able to see the code snippet. So when we call this slice, so this slice example is from this generics function here, slice. Okay, so when we are calling the slice from the here, we normally also write what kind of data type is going to be. So by using compile infer type, you don't have to write it, you just have to write it will get understand with the help of what kind of list you have created from. So if you see letters is a list of character here. So by default, when you call the slice, it will take the same parameter or same data type that you have created from the list. So it is created from the character. So automatically it understand, okay, it is a type of character, and it will call that function with that data type, and it will perform the action. Be make sure that whenever you create a function or class, whatever operation that you are creating in a function, it should work on all the data types. It should not depend on some specific data type. For example, if you're using comparable, right, you have to make sure that all the data types that is going to be used in that function should be a comparable data type. What my example by that is, let's say you want to compare between string. Okay, so you have to make sure that if user or developer providing a data type of uh, a string, it should be fine. But if they are providing some other object which is not comparable, it is going to be error for your code. So just I'm saying, if you are creating a function of generics function, make sure that it should not depend on some particular data type. If it's depend, we will see in the future in the tech talk that how you are going to apply constraint. So to make sure that even though you have applies your code on some basic specific constraint, your function going to be understand that as well. We will see in the coming up. Now let's move to the higher order function. We know our function will not only contains normal parameter like integer or data type, it can also get the lambda as well, right? So how you are also get the type parameter in the lambda, it will work same. So the declaration of normal function, right? Normal generic function. So you started from your type declaration, and in your lambda as well, you can use the same type parameter as a t here. Okay, that means that whatever data type this function is going to operate on, it will also take that data type on the lambda as well. Okay, surely you can create one more data type or one more type parameter as k if you want for your different lambda as well. Let's say you want to work with the integer and string, both integer for your whole function and string for this lambda. So you can add one more type parameter, and you can call this, and you can add k as well here. And you have to make sure you require two different type parameter. Okay, so here just I'm explaining how you are going to use the type parameter on lambda or higher order function as well. So same way, just you have to provide the t and then boolean. Normally we provide the data type name here, but if you providing the generics, you can use t from this type parameter. Cool. Moving forward, the extension part. So this is a small program which is basically predict and update the list. So how it's going to this is just the extension version of it. So let's say this is the implementation of this filter function. So we first created a mutable list, and we wanted to see the predicate that the calling function, this filter, whatever they will provide as a predicate, based on that we will update the list as well. Okay, so here we have says this is the list of authors. Okay, if you see the authors and readers, and we wanted to filter out if it's the author name or not. Okay, since this predicate, if you see predicate here, it is a type of the same which is the type of list. So that means the parameter or argument of this higher order function or lambda should be of string, right? Because here if you see, this is the authors, right? And we are or readers, as reader, both of them are the string type. So if we apply readers dot filter function, that means filter is now going to operate on string, because this t will get replaced with the data type of whatever variable is or list is. Okay, so since this is a string type, the filter will going to update or work on the string data type. That means this is going to return a list of string, this is going to predicate list, maybe this is going to predicate based on the string and return the boolean. So it just predicate with the it should be string definitely, right? And based on predicate it will return the boolean value, and based on boolean value it will update the list. And same list, because if you see at line number 2 or 1 here, it is also a type t. Okay, so that means the return type is also a string type. So whenever compiler compiles your code, it will update T with the understanding data type, which means when readers dot filter get called, compiler automatically like provide T is a string. So here is string, 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 and here is string as well. So now everything looks fine, right, from compiler side, because everything is some specific data type. So now this is how it works on the compiler as well. Cool. Now we'll understand how we create a generics in list as well. It's the same way that how we have created on the class. You just have to add interface list, and t is a type parameter, and this t you can provide in your either your parameter of your function or return type of t of your function. So t will be get replaced whenever if somebody create an object of list or provide the type parameter here, it will get replaced with that data type. Okay, the declaration is same as class, nothing change here. Here is one example. Let's say you have one interface which is a comparable and with the type t parameter. Okay, and there is a fun function called compare to, and it is, and the function is actually having the argument of type t, but return type is int, which is a explicitly said that I want to return as a int type. Cool. Now let's say this is an interface, we cannot create an object, right? So we implemented this interface in a function, or sorry, in a class called string, which is comparable, string implemented comparable. Now there are two options that you can provide parameter, type parameter to comparable. You have to, if you are extending an abstract class or interface which is a generic type, you have to provide the type parameter to it. Either first case, you are providing here as explicitly that you are saying now comparable will be of string type, this is explicitly. And let's say your class is also type parameter, so here is t as well, right? So you will provide that t in the comparable as well. Okay, two way you can identify or give the type parameter to interface or abstract class, either by explicitly providing the name or data type, or you can also create your own class as a generic, and then that generic class will provide the t to the comparable. Okay, that's how or a compiler are going to understand that this interface will be, or this abstract class will be working on this data type. Okay, because you cannot create an object of interface or abstract class. So this is how you are going to provide the this type parameter to them. Now this function compared to will also automatically convert it into string, right? You have seen this example in your recyclable adapter as well. So in recyclable adapter, whenever you are extending the recyclable adapter, right, you provide the view holder. Explicitly, you are saying now we are going to provide the view holder, right? So that's the example of generic class and how you are going to provide to the interface on abstract class. Cool. Now, now we understand, okay, what is the generic class and how we can call the generic class, function, interface, subject class, right? We now so far we are only understanding of we can provide data type of type anything, either string, integer, double, maybe our own class. Now we wanted to put some constraint over this type parameter, right? As I said in the beginning, when you are creating a function, let's say your function can only be work for the numbers in the Kotlin. Okay, so your function, which is a generic function, which can work on only numbers like integer, float, double. Okay, these kind of numbers. It cannot go beyond that, numbers. So how you are going to put constraint on generic class? If somebody try to create your class which is reusable on numbers, they should know that okay, they can only pass number data type, not other data type. So you have to provide some kind of constraint, right? So this is what the constraint on type parameter. So you can put upper bound, which is this is the higher bound, and from here nobody else can create or call this function. What I mean by that, if somebody is try to provide list of string, since string is a not subclass of this upper bound, right? Either it could be number or it could be a subclass of this upper bound. If it's not the subclass or itself the upper bound, it will going to show the error. It will be a compile time error. Okay, so that is why we call the constraint type parameter constraint. We are saying something that this constraint should be first identified, then only this generic function or generic class will going to create, or this generic function is going to get called. Okay, so we have said that this is going to be upper bound and this is the type parameter. If somebody from not from the upper bound, going to get the error. Okay, now let's see the example of it. Now we have created a one half, which is a function, generic function with a constraint of number. So this is the upper bound, and it is returning the double value. Now the interesting part is your upper. We know that highest data type that is going to be a number. The other data type that will be providing as a parameter of value here, it's going to be either some number, integer, float, double, but not other than those classes which are not extending number. So we know that the higher bound is this. So by this we get one more interesting feature is that you can call the function which is currently inside a number. Okay, so that's why you are able to call two double, sorry, that's why you're able to call two double function on value. Since we did not know the parameter of value here, right, it is currently a t, but since there is an upper bound and this is the higher, right, this is like super class, so we can call the function of super class, right? So since t is the number, higher number, which is a superclass, we can call the variable, because we all know whoever extending the number, definitely they are also overriding, or they are also inheriting this function as well, right? So by default, we can easily call the upper bound member function. Okay. So by using the type parameter, this is also what you get. You can easily call the, whatever function is there on the upper bound. So now we have two double. So with that we have calculated just half by creating, by dividing it 2.0. Since value is a t, we call this function with a 3, which is integer. So here it will get converted into integer, and integer to double. There is a function in number, right? It will convert it into integer to double, and then it's get divided by 1.5. Cool. This is what we call the constraint. Okay. Moving forward, there's one more example. This is the example of comparing. So let's say we have created a comparable. Now this is the interesting one. Whatever function or whatever data type we are providing in a parameter, this is currently a string data type, right? Which is going to inside a first and second. You have to check, and this function will check if that data type is extending this interface or not. So we all know that comparable is getting extended by in string, right? So if we try to put our own class here in the max, okay, and our own class is not extending comparable, it will show an error. Okay, so this is just another example that how you can use constraint. And listen as well, the comparable is also a generic interface, so you have to provide a generic type parameter here, right? As you remember in the previous slide, as I said, if the interface or abstract class or a class is a generic class, wherever you are extending that, you have to provide the type parameter to that class as well. Okay, so we are saying whatever function t is there, it will be a same of comparable. Okay, that's why we write t here. Cool. So these all basically the generics are very useful when you are creating a lot of APIs, SDK, libraries kind of thing, also in your own application. Okay. Now this is another example. Let's say if I try to provide, let's say there is some error, right? If I try to say max and both of them is a T type, that means there should be either Kotlin or both of them should be string or both of them should be integer. But here what a developer did is it is first providing the string and then providing the integer value. Now it is going to show the error of type parameter bound for T is not satisfied, because see, if you provide different data type, it will take a super type of it. As we all know that all the data type are extending any, right? So that's why it's saying the error of type parameter bound for t is not satisfy. Infer type is any, because compiler understand, okay, t cannot be string or integer, it must be something which is extending both, which is any. And if you check any is not extending comparable interface. Okay, that's why it's also at the inside the error, if you see, it's saying that infer type any is not a subtype of comparable. As I said in the beginning of comparable, that if somebody is not extending this function or extending this class or interface, it is showing the error. Cool. This is just to show you the error part. Now let's you can also provide multiple constraint on your function or class. Okay, here is we are just asking for a single constraint, that if this is the upper bound only. Okay, now if you wanted to see multiple constraint, that your parameter type should be from both the classes. So here is the example that it is saying we are creating a normal function, data type function definitely with a sequence t, but for multiple parameter you have to use where. Okay, so we used where t, it should be upper bound of char sequence and appendable. So what is the meaning of this, that if there is a data type which is extending both char sequence and appendable, only that data type will be able to call this function or will get passed here. Okay, so we all know string or string builder is the one which is expanding a char sequence and appendable. So apart from this particular data type, if there is a data type which is getting provided here in the ensure trailing period, it will be showing error. Okay, so this is an example of if you want to provide multiple parameter constraint, right? So for multiple you have to use where, and it should be after the function declaration. Okay, cool. uh, Now one more thing in the generics of Kotlin is that by default when you provide the t as a type parameter, it is a null type. Okay, so if you're thinking that your class which is a type t is non-nullable, it's not. It's nullable by default, because if you provide t, and compiler first will understand as an any with the nullable. So that's why whenever you are calling a super class, which is any, right? We all know all the data types and everything in Kotlin is extending any, right? And since any is kind of super class here, we can call the function of it, right? As I said in the boundary, in the number, if it's a super class, we can call the function of the super class. Now we know t, any data type in Kotlin, it is extending any, right? So we can call a function of any. So now if you try to call the function of any, it will say this is a null type. You will try in your maybe id or something. So by default all the type parameter is a nullable. Okay, so if you wanted to maybe create a non-nullable, you have to provide the uh, that data type should not be non-nullable. So by doing that, it will not be it will only accept the non-nullable, but by default it is a nullable part. Cool. Okay, so this is for type parameter constraint and generics, right? So hope you guys this get understand on this one. Now our last topic from this part one, I know this all things are must be not easy to understand, but do let me know, we'll take a question at the end. But this will be a last topic on this, so that you will get the idea of how generics work at the runtime. Okay, in the generics, so normally all the slides I said, the compiler will understand your data type, not the runtime. Because in Kotlin and in Java both, all the data type that you provide by calling that function or that class object, it will be there only for compile time. Okay, so here for example you are creating a processor which is a generic class, and you're providing string here, right? Now, as I said, this will be only compile time. The information will only be preserved that this processor is a generic class, and now this processor object is a string class. This is only be there only compile time. On the runtime, the processor, we cannot identify what kind of data type this processor is going to work with. So this there only be a processor class. There will not be a string, integer, whatever type you have provided here, it will not there. Okay, at runtime, the type has been erased from the Kotlin system. It will only work on processor. So how, since, so you ask the question, if the runtime does not know what data type is going to process or going to be here in the processor class, how it going to work? How it makes sure that this processor will be of type string or type integer or type some custom classes? So runtime, before runtime we do compile time, right? So compile time makes sure that this processor will be of a string type or some data type, right? So it is the responsibility of compiler to first figure out what kind of data type is going to work with on a processor. Now this information will get lost in a runtime, but we all know that compiler did its work, did make sure that this processor will be or some certain type. Okay, without any malfunction. So at runtime it just automatically run the code, and it will just provide all the data of a string. It makes sure. So let's say, take an example of list here. So you have one list of a string, one list of integer. If we provide string here, we all know we have to provide all the data type which is string in the list, right? Because compiler makes sure that this, if we declare list of a string type, it will be only containing list integers, sorry, strings value. If it's a type of integer as a list 2, compiler makes sure that all the values which is assigned or add in the list should be integer. So when runtime come, it only understand list as a class. It will not understand either it's a integer or it's a string. Okay, so that's how the generics works at the runtime on Kotlin or Java, that it will not get any information on type. Now from this topic there is another topic of refined, which is how we also provide the information of generics on runtime. Okay, and then there are topics of covariance and variance. We will understand them in the next talk further on this one. So this is first. I just wanted to give you heads on that how things work on runtime and how we can overcome by using refined generics functions as well, by providing information at runtime. Cool. That's all from this generics one. If you have any question, do let me know. This is